In this video, our focus will be on the software component of the timer with a water level controller. We aim to provide a comprehensive explanation of the functional modules incorporated in this project. Function delay_init. This function initializes the system clock tick for the delay function. Here we initialize the input-output pins as per the requirement. We have to put the main relay and trigger relay off during power up. Timer 1 interrupt initialization for time counts in the code. Call the routine for displaying the logo. Read the set countdown value from data flash memory and put that value in the associated variable. After soldering a new and fresh microcontroller, despite burning the application code, the data flash area remains blank. Consequently, all FF values are obtained when reading this data flash area, causing the read value to exceed 999. Therefore, assigning a default value of 10 to the countdown time variable is necessary if its value exceeds 999. We utilize this function hex to BCD to convert the countdown hexadecimal value into a binary coded decimal value, which can then be displayed on the 7-segment display. Bypass the timer 1 interrupt count runtime. Start the pump at power startup. For any embedded system we must write this for an infinite loop. Calling the function which scans the tactile 4 switches to detect its state. Again call the function hex to BCD to convert the countdown hexadecimal value into a binary coded decimal value, which can then be displayed on the 7-segment display. After the countdown value is displayed, the routine monitors the pressing of the increment/decrement switch. Once the countdown display times out, it verifies the status of the pump, on, off, and shows off accordingly. Checks the countdown over flag in the timer interrupt to put the pump off and update the status flag. When the tank reaches its full capacity, the pump is automatically turned off. However, the system ensures that the full sensor is repeatedly checked multiple times before deactivating the main relay. This precautionary measure is taken to prevent any potential disruptions caused by noise or stray signals. The routine scans the tactile switches for various functions, including starting and stopping the pump, as well as incrementing and decrementing the time value. The 3 input-output pins that are connected to the tactile switches are also shared with a 3-digit LED display. Countdown value increment routine. If the digit 1 pin used for the display is not selected, i.e., its state is low, it scans the common input pin SW_COM, which is connected to all 4 switches. By combining the status of the 2 input/output pins, we can determine the switch status and take the appropriate action accordingly. To prevent false triggering due to electrical noise, a slight delay is introduced for practical purposes. Increase the countdown value and save it in the data flash memory. Similarly, it checks the digit 2 pin used for the display for decreasing the countdown value. The digit 3 pin used for the display is used to stop the motor. For starting the motor we have used a dedicated pin. Let's now examine the allocated I/O pins for the display system. To align the output pins driving the 7-segment display modules in a sequence, we utilize this code snippet. The code is self-explanatory. We will now conduct an experiment using the display system and a test code. The video will not have a voiceover, but it will include captions. Additionally, we have incorporated background music that aids in enhancing concentration. Therefore, please concentrate your mind and attentively observe the experiment.